Here's what we're going to do. We're going to try this again with 3 sets. So you're going to help me decide on what the 3 sets should be. Now, when we throw in 3 sets, at first we have to show all 3 intersecting. Even if it's possible, they might not, just in case. So it's possible one of these sections might have nothing in it. For example, if one set was blue and the other set was red, how many pieces are both red and blue? In this universe, none, right? Okay, another thing, how many different regions do I have? If I count them, there's the outside, there's that totally center part, right? So there's 1, 2, 3, 4, 5, 6, 7, 8. So 3 sets split a universe up into 4 corrals. And we got to figure out what's going to go in each corral. So I need some labels.
Yellow.
Yellow could be one of them, yes. Taylor?
Not red.
Not red. Ooh. And Caleb?
Blue.
Blue. Oh man, all colors. Okay. So now we have to figure out what goes where. Now, since we did pick colors, that means, because we don't have overlapping colors, some of these intersections are going to be empty. But the not red throws a kink in that. Okay, so that's a nice one. So usually what I do is I start with the center region, because that I think is usually the easiest one to define because it's got the most characteristics. So I can zero in on what it is. So in that center region, that would be yellow, and I'm going to call NR not red, and blue. Well, I can't be yellow and blue at the same time, so I'm pretty sure there are no pieces in that region. That make sense?
What about green?
Oh. Let's say we're not mixing colors here, and it's yeah, green is different than yellow or blue, or yellow and blue. All right, that's a tough one, yeah. Okay, yeah, let's go with that assumption, otherwise we'll get a different answer. Okay, so then this is where it gets really hard. Where are my colors? Come on, there you are. So this wedge right here, that's the set of pieces that are both yellow and not red. We've already accounted for the blue versions of those guys. There weren't any. Okay. Are there any other pieces that sit in this upper part of that football type shit segment there that are yellow and not red?
All of the yellow pieces.
Yeah, all the yellow pieces happen to be yellow and not red. And we have what? 8, is that right? Mm-hmm. Pieces. So I'm pretty sure there are going to be 8 pieces that are yellow and not red. How many yellow pieces altogether are there again?
8.
There are 8. So how many go in this section over here?
0.
There's none out there because we've accounted for all of the yellows. All right, how about this from the center, the lower right piece right there? To be in that section, what has to be true? That's outside of yellow, so we can't have yellow pieces, right? We've accounted for the yellows. You have to be not red, and you have to be blue to be in that place right there, which would be all the blue pieces, yeah. So there should be 8 pieces right there. So do I have an answer for this lower part of the blue area?
0.
That should be none because we've accounted for all the blues. So just double check if you're not looking at your sheet. We've accounted for all 8 blues, so that means in this disjoint region right here, there's nothing. So we'll describe that region with set notation in a minute, what that is, but let's keep moving. Coming down here, I've accounted for all of the yellows, so there really can't be anything down here. So the question is, does it make sense that there really are no pieces here? This region right here, how do I define what's in this region?
Both yellow and blue.
They're both yellow and blue, and they can't be. Pieces are strictly yellow, strictly blue, strictly green, or strictly red. There's nothing that fits that category. So yeah, it makes sense there's nothing in there. All right. Now, next we have that not red set. Okay, so not, what does it mean? What's another way I can describe not red? Yellow or blue or green. Okay, we've accounted for the yellows and the blues. We haven't yet accounted for the greens. How many greens are there? So there should be 8 pieces right here. And so the trick is finding a way to reason through this. You can do it in different order. It just kind of depends on, what crosses your mind at the time. Let's see, 8 plus 8 plus 8 is 24. We have 8 pieces unaccounted for because we need 32 total. So we're going to make a wild guess and say how many pieces live out here? 8 of them? Okay. What defines a piece out there? Well, anything out there can't be yellow, right? And it can't be blue. And it can't be not red. Okay. If you can't be not red, what must you be? Red. So those must be the red pieces. So we happen to pick sets that distributed our colors each into their own little pocket. So we have our yellow pieces over here. We have our blue pieces over here. Our green pieces live there, and our red pieces have to live outside the box. All right, so now I'm going to ask you some questions based on this Venn diagram. Okay, so everyone have this written down somewhere? Okay, because I have to make the screen go away for a moment. I want to know, let's see, what is the number of pieces that are yellow or not red? And the Venn diagram should be able to identify that answer for us. Number of pieces that are yellow or not red. It's more than 8. The pieces that are yellow and not red would be 8. That would be this green area I did there.
Oh, yeah.
I probably should have done that a different color.
So if it's the pieces that are yellow and not red, with the pieces along the outside, the red pieces, do those get counted into that, or just what's in the circles?
So yellow or not red. So that means they have to fit the quality of being yellow, or they have to fit the quality of being not red. So it's more than 16.
I had 24.
It should be 24. Yeah. So or is a union. So let's see. I guess I'm going to use my yellow highlighter. So the union of those two sets is this figure 8 shape. And so there's 8 plus 8 plus 8 or 24 things in there. Double checking, looking at my pieces, I want to check off any piece that is yellow and any piece that is not red. So to do that, I can just look at back of my pieces here, and I can just scribble on this. Oops, I need to copy it. So I can scribble on it. Okay. So I'm interested in any piece that's yellow, so I can mark those. Oops, that's not a pen. I can mark those off. And then I want to mark any pieces that are already marked that are not red. Okay, so those are all the pieces that are either yellow or not red. The or says just grab them all. And so I have what? 4, 8, 12, 16, 20, and there's all 24 of them right there. So once we complete a Venn diagram like this, we can answer a lot of different questions about different categories of putting together with ands and ors and things like that. All right, let's try another one. Next. So we calculated that to be 24. How about the number of pieces that are not yellow? Can we look at the Venn diagram and pull that number out? I see 2 ways to do it looking at the diagram. How many yellows are there? So everything else has to be not yellow. So we can just do a subtraction because we know the size of the universe is 32. The other way we can do it is we can just look outside of the yellow set. And so grab any number that's outside of this circle is something I'm interested in. So I have 3 8s outside of the circle, and so I get 24 that way too. So part of what we're looking at here is Venn diagrams as a way to categorize stuff and also as a way to solve different kinds of problems. Has anyone started working on the section 3 homework yet? Okay, there's a wicked cool problem in there. And ooh, are we out of time? Okay, let me just show you this problem quick and then I'll shut up. So let's see, do I have the homework up anymore? It is gone. Okay, let's bring it back up. Only I can remember which number it is. And I'll just make a note about it now and we'll do it together next class, but I highly encourage you to try it on your own. It's a fun problem. If you like challenging fun. 2, 3. And it's probably near the end. Not that one. Not that one. Not that one. Uh-oh. Oh, where is it? Which did I start with, 11 or 10? There it is. Okay. So let's see. Let me copy this into my screen. And excuse me, when you get it, you'll each get a slightly different set of numbers, but the idea is the same. Screenshot. All right. So we have this information right here to deal with. And then we have this other bit of information right here. So I'm sure you all know that blood is categorized in different ways. Does anybody happen to know what their blood type is? I can never remember mine. I have it in a card somewhere, and it just eludes me. But there's different antigens. So there's 3 kind of antigens in the blood. There's A, there's B, and there's RH. Okay, and there's RH positive, and then there's RH. So RH positive means RH is in there, and negative means it's not in there. If you have neither A or B, then that means you're O. Okay, so 117 people were tested by the Red Cross, and the Red Cross found 48 of them had type A, 18 had type B, 82 had RH antigen in there, 5 of them had both A and B antigens in there, 31 had A and RH, so that would be like RH positive, 11 had B and RH, so that would be B positive, and 4 had A, B, and RH, so AB positive. And so what we want to do is, based on this information, if, and again it says if A and B antigens are missing, that's how we type up blood as O. How many of the people in this group are A negative? And just like we played around with Venn diagrams in these shapes, the way to solve this is with Venn diagrams using A, B, and RH. And then you start deciding which of those disjoint regions these numbers go in. Now keep in mind, there's a lot of different ways to draw your Venn diagram. So I'm going to bias you right now with my way to draw it. And not that it's the best way. It's, oops, that is the wrong marker. Where's the magic one? There it is. So you might want to experiment. Since they talk about the blood type as based on 3 different types of antigens and the absence or presence of each of those antigens, we should just be able to classify people by making 3 different sets, where one set is A, one set is B, and the other set is the RH. Now, if somebody is both A and RH, should use a different color, that means they are actually in this group right there. Now, in that group, there are actually 2 types of people. Agreed? Okay. There are because it doesn't say they are A and RH, but not B. Do you see a not B there? It does not say not B, so I don't know about those 31 people. However, what do I know down here?
How many
Yeah, I know there are 4 of them that meet all 3 antigen tests. If there's 31 total in that crescent type shape, do I know how many are A and RH but don't have the B?
So it'd be 31 minus 4.
31 minus 4. So there's 27 that live in that group right there. So you want to be careful when you throw these numbers in. And I made a note before. A lot of times I'll put notes like there are 48 A's. I just accounted for 4 and 27 or 31 of them. Okay. So the other 17 have to, some of them live here and some of them live there. I don't know which yet. So you got to kind of troubleshoot around this map to figure it out. So give yours a shot, and then on Monday, we'll get together and do some of these together. We'll pick on a couple of different people, see what their numbers were, and see if we can get the same answer. So that's like I think this is like the hardest problem in the whole homework. So I've covered all the major topics in chapters 1, 2, and 3. Our next class is just to tie up loose ends, and then we're gonna have an exam on Wednesday, a week from today. I mentioned last class I would post a sample exam. And so in that other resources section, I posted a sample of a test I gave a couple years ago. And yours will be pretty similar to this. Because this stuff is pretty complicated and hard to do, like, if somebody says, hey, on the spot, solve this problem for me, I might not be able to do it in an hour. I might need to look back at it later. So usually what I do with a test like this that has some pretty hard problems, I give part of it as take home. So on Monday, I'll give you the take home part, and you have the week to get the take home part done. And then on Wednesday next week, you'll have a short in-class part. So the test will be about 50% take home, 50% in class. This test right here is a combination of both the in-class and the take home. Okay, so combined, your total test will be about this long. The in-class portion will definitely not be this long, right? And I always make practice tests way longer than the real one, just to give you more stuff to practice for those that want it. All right, so we're almost done with the first unit of the class.